When studying acid-base chemistry, one of the theories on determining the acid and the base in a reaction is called the Bronsted-Lowry Theory of acids and bases. Now, in the Bronsted-Lowry theory, an acid is defined as a substance that donates a proton. Now, a proton is defined as simply an H plus, okay, an H plus ion, so a hydrogen ion. So an acid is considered a proton donor in the Bronsted-Lowry theory, and a base is considered a proton acceptor. Okay, so you notice that as the ammonia here goes through the reaction and becomes the ammonium ion, it does so by accepting an H plus. Now, one of the other key concepts of the Bronsted-Lowry theory is the identification of what's called the conjugate acid and the conjugate base. Okay, because in these reactions, what they found is when you react a weak acid, weak base, the reaction is reversible. It doesn't go to completion. Not all of the protons are donated, so therefore they're not all received, and the reaction is reversible. So in a Bronsted-Lowry theory, you have the original reacting acid and base pair on the left side of your reaction, okay, because those are your original reactants here on the left side, and as they go through the reaction and the acid donates the H plus and the base receives it, then you produce a new species of acid and base that are called the conjugate acid or the conjugate base. And how these work is the original acid, like this sulfuric acid right here, when the original acid donates the H plus, the remaining species, what is left behind of the sulfuric acid, is called the conjugate base, because you see, if this conjugate base species were to reverse itself and come back to the original acid species, notice what would happen. It would accept an H plus, a hydrogen ion. Okay, that is the reaction of a base, because in the Bronsted-Lowry theory, remember that an acid is a proton donor and a base is a proton acceptor. Okay, so a base is a proton acceptor, and see, if this conjugate comes back, he would accept that H plus. Notice this base, the original base, what happens is there's a proton acceptance there. See, now this conjugate acid, this new species that's made, if it were to reverse itself and come back to its original species, it would donate that H plus. See, and that would be the property of an acid. So a base reacts, and its new species is a conjugate acid. An acid reacts, and its new species is a conjugate base. And we see that in all three of these examples. Okay? Now, a little trick of the trade is the original acid and base pair will be on the left side of your arrow, of your yields arrow. The conjugate pair, the conjugate acid and the conjugate base, will be on the right side. Now, here's another picture for you to make this a little bit more relevant. So we pair these up. We call these the conjugate acid-base pair. The original acid with its conjugate base, or the original base with its conjugate acid. Notice the difference in these two species. These two species. A conjugate acid-base pair, so a pair of species that is the acid and then the conjugate base, or the base, and the conjugate acid, that pair will only differ. They only differ by a single. Only differ by a single proton, a single H plus. Okay, you see we've got the H2O and the OH negative. The difference between these, an H plus. The NH3, the NH4 plus. That's a difference of only an H plus, a single H plus. Sidebar here, H2SO4, okay, sulfuric acid, a strong acid. It donates a proton, which would mean its conjugate base is HSO4 negative. Okay, now this conjugate base could potentially, in a separate reaction, be an acid and donate another proton, which would then leave it being SO4 negative 2. So this would be its conjugate base. These two right here are a conjugate acid-base pair. Okay, these are paired. These two are paired. This is a conjugate acid-base pair. See how the two pairs, they only differ by a single proton. This right here is not. This is not a conjugate acid-base pair. They do not differ by a single proton, they differ by two protons. Okay? A conjugate acid-base pair will only differ by a single proton. A single proton, a single H plus ion. Okay? So in Bronsted-Lowry acid-base theory, one of the important concepts to understand is conjugate acids and bases and how they relate and how they themselves can continue the reaction and influence your final pH value of your solution.